Welcome back to CAD/CAM tutorial. Today we are going to design and assemble a simple gear speed reducer. You can see here input shaft rotating at high speed and the output becomes very slow. So this is the aim of this gear reducer. I wish you like it. So let's see how to do in Solidworks. We will design each and every gear and assemble at the end. I'm sure you like it. And we will do some little animation at the end. So let's start how to do in SolidWorks. Make the first part of gear reducer input shaft. So let's start. Choose front plane, sketch. Draw here a circle with 8 mm diameter. Okay. And extrude it up to 40 mm. Okay. Now see here. Now choose top plane, sketch, normal. Draw a center line. Now choose here straight slot and draw one straight slot. Now let's define the mid distance 4 mm and keep the radius 1.5 mm and distance from one end 5 mm. Okay, and select extruded cut. Select here offset 2.5 reverse direction through all. We want to cut. Okay. Now see, we cut the groove passage for key. Now select this face, sketch, normal. Let's draw a center line. Vertical construction line, choose center rectangle. Okay, select these 3 lines and make relation symmetric and define the length width 0.6 mm and the distance from center line 4.5 mm. Okay, now select extruded boss. Select reverse 10 mm. Okay. Now we want to make multiple number of patterns. So choose here circular pattern. Select this edge. Here select this extruded face and select circular path. We want 10 number of patterns, so here 10 we selected. Okay. Now see, choose chamfer, keep 0.5 and select this end. Okay. Now this is our input shaft. Let's define the material. I prefer to give chrome plate, but for my look I prefer aluminium look. Now save. Go to desktop and create a new folder, gear reducer, gear speed reducer, and this is the part 1 input shaft. Let's see the next part. Now here we will make the next part, shaft, speed shaft. Choose front plane, sketch, and here draw a circle. Keep the diameter 10.229 mm. Okay. Draw vertical center line. Choose center rectangle. Exit. Select these three lines and make relation symmetric. Now it's time to define. Keep the width 4 mm and define the distance from center line 7 mm. OK. Choose trim entities. Now trim these parts. OK. Now the geometry is fully defined. So go to feature, select extruded boss. Extrude up to 30 mm. OK. Now select this face, sketch, normal, and here draw two circles, one exactly the same previous circle and one just bigger than the dimension. Make sure it's bigger. Select extruded cut. Now we want to cut mid, so choose here offset. Keep 10, reverse, and this one select, cut out only 10 mm. See, we want to cut in mid portion only. No. OK. Now see, we prefer aluminium plating. Now save this. Part number 2 is speed shaft. Now let's do the next final shaft. Let's do the next shaft, output shaft. Choose front plane, sketch. First draw the same circle and keep the diameter 10 mm. OK. Now here we will make one groove for key. First draw a vertical center line. Make sure it is vertical. Choose center rectangle. Now select these three lines and make relation symmetric. Now define the width 4 mm and distance from center point 7 mm. OK. Choose trim entity and trim this inside unnecessary lines. OK. Now it's fully defined. So extrude it up to 10 mm only. OK. Now again select this face, sketch, normal. Draw here a circle with 10 mm diameter or the same circle. Now extrude it and extrude up to 30 mm. OK. That's it. Now we want to make a groove for shaft key. So choose here top plane, sketch, normal, and let's make a groove here. Center line. Choose here straight slot. Let's define 3 mm. The mid gap 5 mm. And the distance from bottom edge, let's say 5 mm. Now it is fully defined. Sketch. Now here select extruded cut. Keep offset. .5 mm. Select here reverse through all. OK. Now see, in upward direction we cut a groove. Select .5 mm. OK. Now I defined polished steel. Save as part number 3, output shaft. Okay. Now here we will make the next part in speed input gear. Choose front plane, sketch, draw here 2 circles. Let's keep outer diameter 20 mm. Inner 8 mm. Draw vertical center line. Now here select corner rectangle, define 0.6 mm. Okay. Select these mid 3 lines and make relation symmetric. Now define the distance from midline, midpoint 4.7 mm, 4.5 mm. Okay. Choose trim entities. And trim it. Okay. Now we want 10 number of this pattern, so select here circular pattern. Here select these 3 parts, 3 lines, and make 10 numbers. Okay. Choose trim entities and delete this extra parts inside, extra lines. Okay. Now this is fully defined, so let's extrude it and extrude up to 10 mm only. Okay. Now see. Now select this face, sketch, normal. Here we want to cut some groove, so first draw a center line. Now select this outer circle and convert it. Okay. Choose line, connect with, again select line, connect with this circle. .5 mm. Okay. Now we will make one relation. Select both the end point of line and select midline and make relation symmetric. Okay. Now define, it's time to define the angle. One side 20 degree and the another side also keep 20 degree. Now define the distance from midline or center point, 8.5 mm. Okay. Now it's time to cut this face. Select extruded cut. Select here, select these 2 faces, keep here through all. Okay. Now see, now we want to make multiple number of cutouts, so choose here circular pattern, select this cutout and here select the path, choose circle. We want 14 numbers. Okay. Now see, now let's create one mid plane. Select here plane, select this face and back face. Now see, in mid position going to create a plane. Okay. Now select this plane, sketch, normal, draw here 2 circles, 15 mm and 12 mm. Okay, and try to cut. First choose offset, keep 4 mm reverse direction, select here through all. Okay, now see, we cut some groove here, make chamfer, select 0.5 and select this edge. Okay, now we will try to mirror this. So select this mid plane, mirror, select this cutout and select chamfer also. I think delete this, we have to do one by one. Plane, mirror and select here cutout. Okay, now see, choose plane, chamfer, 0.5 mm and select this edge. Okay, now hide this plane, choose fillet, 0.25 mm and select this edge. Now see here, connect to start loop 55 edges. Okay, now all the edges selected. This is very important command, it saves your lot of time, so make sure. Okay, now see, our input shaft, input gear is ready. Let's assign the material chrome plate. See, any material you can. My look is like a real view because my real view graphics is active. Now save this. Part number 4, input gear. Save. Let's see the next gear. Now the next gear is output shaft, output gear. So choose here front plane, sketch, draw here 2 circles, keep outer 60 dia and inner 10 mm. Okay, select here center line, corner rectangle, exit, select 3 lines, make relation symmetric, .6 mm, 4 mm, and distance from midpoint to top line 7 mm. Okay, now this line drag inside, trim entities and trim these lines. Okay, now our geometry is fully defined. So select extruded boss and extrude up to 10 mm. Okay, now here we will make the gear teeth. So select this front face, sketch. First do one thing, select the outer circle and convert entities. Second thing, make center line. Select line, draw a line, exit, again choose line, connect with outer circle. Now we will create one relation, concentric. Select both the end of line and mid line and make here relation symmetric. Okay, now it's time to define angle. 20 degree, 20 degree. And 1.5 mm width. Okay, delete this relation. Now drag upward. Choose center line, dimension, and define from 28.5 mm from origin point. Now it's defined. Select extruded cut. Select this face. Select here through all. Okay, that's it. Now we will make multiple number of threads. Choose here circular pattern. First select this cutout, then choose this circular path. We want 45 number of teeth. Select here 45, equal spacing, 360 degree. Okay, that's it. Select this face, sketch. Select circle and draw one circle and keep the diameter 50 mm. Okay, and select extruded cut. Extruded cut. Cut only 2 mm inside, and here choose thickness 10 mm and inside direction, one direction. Okay, now see, choose chamfer 0.5 mm and select this edge. Okay, now we want to mirror this, so first we have to create one mid plane. Select one end and opposite. Now see, it's going to create a mid plane. Okay, now select this mid plane, mirror, and select extruded cut. Opposite, see, it's mirror. Choose chamfer 0.5 mm, select this edge. Okay, now see, the gear body almost created. Hide this plane. Now it's time to put some fillet 0.25 mm. Select any one edge of top, and here a window will pop up. See, it is asking, so select first one, connected to start loop 179 edges. First one. Okay, once you click, it will select it for all the edges. It is very important. If you miss, you have to select one by one all, and it takes too much time. Okay, now our output gear is ready. Let's assign the material. Select full body, chrome plate. Now see, this is our output gear. Now save it. Save as part number 5, output. Gear. Now here let's do the next part, middle gear. Choose front plane, sketch. Draw here 2 circles. Outer one keep 20 mm and the middle one keep 10 mm. Let's draw a center line, corner rectangle, exit. Select these 3 lines and make one relation, symmetric geometry. Okay, keep the width 4 mm and the distance from origin point or center point from the top of groove 8.5 mm. Okay, take it down. Sorry, make it 7 mm. Okay. Choose trim entity and trim the unnecessary lines. Okay. And it's time to extrude, and extrude up to 10 mm. Okay. Now see, now here we want to cut some thread, so select this face, a sketch, normal. First draw a vertical center line, exit. Now select the outer circle and just convert it, or either you can draw it. So I prefer to convert it. Then select line, draw a horizontal line and connect with this circle. Again choose line and up to this circle. .5 mm, angle 20 degree, and this also keep 20 degree. Okay. Now here we want to create one relation. Select both the end of circle and mid center line and create one relation symmetric. Okay. And define the dimension. The bottom line from origin point 8.5 mm. Okay. Now it's time to cut this thread. This cut. Select this. Keep here end condition through all. Okay. Now see, we cut a thread, gear thread. Select circular pattern. We want multiple number of patterns, 14 number of patterns. Select this path and select this cutout. 14 number of pattern, equal spacing. Okay. Now see, choose fillet 0.25 and select any one line. Now it will ask you some relation, so select this first one, connected to start loop 55 edges. Okay. Now it will automatically select all the edges. Okay. It saves you lots of time. Now select the part, go to appearance, and here go to chrome. Any material you can choose, it's up to you. I prefer chrome plate. See, now save this part number 6, middle gear. Now let's make the body. Now let's make the last part, gear reducer body. Choose front plane, sketch. Select here center rectangle and draw a rectangle. Let's define. Keep the length 119 mm, width 70 mm. Okay, and extrude it 35 mm. Okay. Now select this face, sketch. Select circle, select the outer line and draw a circle. Define the distance from outer edge 40 mm and the diameter 16 mm. And select extruded cut. We want to cut inside up to 8 mm. See. Now select this top face, sketch, normal, and here we want to make some cutouts. Select here center rectangle. Okay. Now here we will define some relations. Select both this outer line collinear, in top also collinear. Now select this all lines and make one relation equal. Okay, and define this, select this three widths also equal. Okay, it's time to define 8 mm, 14 mm. Now keep the gap between two lines 6 mm. Here also keep 6 mm. Okay. Now select here center line and choose this center line and draw one center line here. Center line of this cutout, this again draw one more center line. And now it's time to define 15 mm. These two lines 39 mm, and select the overall length 89 mm. See, okay. Select this mid line, (15 mm). Okay, now we want to connect this all lines, so choose here line, exit. Now define these lines 7.5 mm, 15 mm. Okay, choose trim entity and trim this lines and create one passage. Okay, now here the passage created. Now it's time to define here escape, exit. Let's define 7.5 mm, 15 mm. Okay, choose trim entity, yes. Now here also the passage is defined. So this is the passage, it's already defined. Okay, (89). Okay, now the geometry is fully defined. I hope you note down all the dimensions. Just check the dimension from another edge, 8 mm by default. Okay, now select extruded cut. See these cutouts and make the depth 32 mm inside. Okay, see, now select this face, sketch, circle, draw one circle here, let's say 15 mm diameter, and the distance from bottom edge 79 mm. See, and select extruded cut, keep here 8 mm. Now see, so this is our input and this is our output passage. So perspective, so it looks real. Now again choose this upper face, sketch, normal. Now here also we want to cut some passage, corner rectangle, 1 and 2 and the third rectangle exit. Now it's time to define 5 mm and this end also 5 mm. 5 mm and this also 5 mm. Now select upper one, five mm in all directions. Okay, now it's time to cut. See these three rectangles we want to cut, and cut up to through all. Okay, now see, now here we want to make some cutouts. Select this face, sketch, select this line, circle, and this line, offset. Keep 3 mm only. Okay. Select line, connect bottom edge, exit from the line. Now choose here cut. Cut inside up to 5 mm. Okay. Now see, we created a groove. Now select this face, sketch, normal, corner rectangle, select this corner, go to feature, select extruded cut. Cut inside up to 2 mm only, not more than. Okay. Now the same, select this face, sketch, corner rectangle, and select this corner up to the last corner. Okay. Now select again extruded cut and make the depth 2 mm. Okay. That's it. We created groove here. Now the time here, sketch, corner rectangle, select this end to the last end. Okay. Extruded cut. Let's say 2 mm. Okay. Now select the another end, sketch, normal, corner rectangle up to cut, keep 2 mm. Okay. Now see, select this face, sketch, normal, corner rectangle, select the inside corner and the end point. Extruded cut 2 mm. Okay. Now select this face, sketch, normal, select this outer lines, offset, keep 3 mm. Okay. Select line, connect from this point to this point and up to here, exit. Trim this extra line here. Okay. Extruded cut and make the depth 5 mm. Okay. Now see here, we created the grooves in every direction. Now the opposite direction balance, select this face, sketch, corner rectangle, this corner to this corner, extrude cut, keep 2 mm. Okay. Now the same as here inside sketch, select this corner to end, extruded cut, depth 2 mm, okay. Select inside face, sketch, corner, select this inside edge, just rotate this edge, cut, depth 2 mm, okay. Now just rotate your, now this wall sketch, corner rectangle, select the inside edge and select this outer edge and extruded cut 2 mm, okay. And the last wall, select this outer wall, sketch, corner rectangle 1 and 2, another end, exit, extruded cut and 2 mm, okay. That's it. Now choose chamfer, fillet, keep radius 0.5 mm and select this first connected to start 19 edge, select. Now I think it is clear. Again choose this face, second one, no, okay. Let's choose one by one. All inside corner and same as opposite direction. Okay. Fillet 5 mm. Now this time choose outer. Select connected to start face, first one. Now here selected all. It saves my lot of time. Okay. Again choose fillet. Now select one corner. Now here it is asking select no. This also not. So I have to select here one by one. Okay, this end finish. Let's go to the next end. Now all the end selected. Okay. Now see. Now let's make the face here. This face, sketch normal. Select center rectangle. Draw one rectangle. Select this rectangle for construction geometry. Okay. Now let's define 93 by 64 mm. 3 mm, 3 mm. Okay, choose circle. Define circle in every corner. And two circles this corner also. Okay. Define this gap 3 mm. Okay. Now we will make one relation equal circle. So select all the circles one by one. Press shift key. Equal. Now all the circles are equal dimension and define any one circle 3 mm. Okay, now it's time to make a hole. Extruded cut 10 mm. We want 10 mm depth. 10 mm here it will come out, and this one will go inside. Okay, select this face again, sketch normal. Again select corner rectangle up to here. For construction geometry, okay, let's define the length. 113.5 mm, 19.5 mm. Okay, let's define exit. Select this one line and make relation vertical. Okay, now define keep 2 mm. Let's check how much here. So this one make 1.75 mm, and from this line keep 3 mm. Okay, actually we want 2 mm, but do one thing, delete. Let's delete this dimension and make it 20 mm. Now try 2 mm. Okay, select circle, draw circles in all 4 corners. Define the diameter 1.8 mm. Okay, select all the circles and make relation equal. Okay, now here we want, there is no gap, so let's reduce it 113 mm. Now here we have enough dimension. Select extruded cut 10 mm. Okay, now see the hole is created. So this is the our body or housing, you can say gear housing. Define the material iron, cast iron. Cast iron, and let's define okay, keep little bluish. Okay, now let's save this body. Now gear speed, part number 7, housing. Save. This color looking little dull, so here one more option in painted. This looking very vibrant, and here we can little play so that okay, this is metallic color. Save it. Now let's start the assembly of gear reducer and gear. We forget to add here some body extruded part, extrusion. So select this inside face, sketch normal. Select here select circle, keep diameter 15 mm, select line, exit, choose trim entity and delete this half circle. Okay, now select this length 32 mm. Okay, horizontal. Now select, now you can see inside. Now we will extrude this face. See, reverse direction 6 mm because the wall thickness is 6 mm. Okay, now see, it's close. Now the same we will do it here. Sketch, circle, let's make normal. Okay, find out this circle midpoint. Okay, define the diameter, same 15 mm. Okay, select line and connect with this point. Exit, select this line, make relation horizontal. Now define 32 mm length. Okay, we want to trim the half circle. Okay, delete this relation. Okay, now define, sketch is fully defined. Select extruded body. See, reverse direction 6 mm. You can see it here inside. Okay, that's it. See, now the body is fully defined. Now save it. Now this complete body, complete housing. Now we can start the assembly. Now here let's start the assembly of gear speed reducer. Select here new assembly. Okay, now this is the Solidworks assembly window. Let's browse our first part. I prefer to choose housing first. By default housing will be fixed. White background. Okay, this is the our housing. Let's browse the our next. Select here input shaft. Let's rotate. Select this inside circular face, matte shaft, concentric relation. Okay, now go to design library and we will bring here one bearing. Go to toolbox, select here ISO standard bearing, ball bearing, and choose here radial ball bearing. Just drag this ball bearing to shaft. Now a window will come here. Here we will define the material standard size 388. That's it. Select here detailed. Okay. Cancel. We need only one bearing. Select the back face of bearing matte and this face. Coincident relation. Okay. Now shaft rotating inside. Now we want to make one more relation. Select the bearing, one plane, matte, this face. It is fixed with this face. Okay. Okay. Now let's browse our next component. Bring input gear. Choose here directly matte, select the shaft and select the internal hole, concentric. Okay. Now here very important relations. Select this cutout edge and this shaft edge. Make relation coincident. Okay. It is very important relation. Now it is moving with shaft. Select this valve and gear valve and keep the gap between 2 mm. See. Okay. Now our first input shaft and input gear is fixed. That's it. Now it's time to add another shaft, speed shaft. Okay. Select shaft, matte, select this circular face or half hole, concentric. Okay. Just drag in mid. Okay. Now here we will add one bearing. Select ISO ball bearing and select here angular contact ball bearing and drag up to this shaft. Now a window will come here. Here we will select the size of bearing 1700 ton. Okay. Cancel. Let's define this. Select this valve and the bearing matte, bearing valve and housing valve coincident. Now this shaft fix inside this bearing. Okay. Now it's time to bring the big gear, output gear. Better make in particular position. Okay. Select matte, select the whole of gear and shaft and make relation concentric. Okay. Just rotate the position, drag inside. Now here we will make one relation. Select this bearing gear, this line edge and this edge. Make relation concentric, coincident. Okay. Now here also select this gear face and small gear face. See, coincident relation. Okay. Now both in particular perfect position in one line. Now adjust the teeth. We need to adjust. Select this face, select normal. Select the body and choose here change transparency. Select this any one gear in mid, then try to adjust position. Okay. This is perfect. Change transparency. Matte. Clear. Go to mechanical matte and choose here gear ratio. Now first select this outer face of small gear and this outer face and keep here ratio 20/60 reverse direction. Okay, okay. Now let's try to rotate a small gear. Okay, this is going perfectly. That's it. Now it's time to add next gear. Browse middle gear. Choose met. Select the shaft and gear hole coincident, concentric. Okay. Here select the gear edge and shaft edge. This is coincident relation. Okay. Now it is rotating with the same gear. Okay. Now again browse our speed shaft, met, and this block circular face concentric. Okay. Now browse the bearing, and the same bearing angular contact ball bearing. Drag up to this shaft, and here it will ask the dimension, size. We will prefer the same size here, 1700 by 10. Okay. Okay, cancel. Select the ball bearing face, met, housing wall, coincident. Okay. Now the ball bearing is fixed. Let's bring the big output gear. Select this inside hole of gear, met, shaft. Okay, this is concentric relation. Drag inside. Okay, come to this edge. Select gear one edge and shaft one edge, coincident relation. Okay, now the shaft also fixed with the gear, but still it is okay. We will make one more relation. Select this face and this face, coincident. Okay, now it will rotate. That's it. Now select this face, normal, change transparency. Now adjust the gear teeth. Keep any one gear in middle and adjust the second gear. Try to keep in mid. Select change transparency. Choose mat. Clear mechanical mat gear, and here first select the small gear face, then big gear face. Output the same 20 by 60 mm. Okay, okay. Let's try to rotate. See, it's rotating. Now it's time to add next gear. Browse again middle gear. Select inside hole, met, shaft, concentric relation. Okay. Select gear one edge and shaft one edge, and here it comes coincident relation. Okay. Now let's see. Okay, both rotating. Okay, now it is near to final stage. Browse our next shaft, output shaft. Rotate the shaft. Just key area slotted, keep this slotted area keep outside. Okay, select mat, and this circular face concentric. Okay. Here also let's browse the gear. Radial contact ball bearing, angular contact ball bearing. Keep the same 1700 by 10 mm size. Detailed. No cage. Okay. Cancel. Now let's fix the ball bearing. Now it is rotating along with this shaft. So select the back face of ball bearing and inside face of housing. Okay. Now it's fixed. Let's bring the another output gear. Select whole of gear, mat, shaft. Coincident, concentric relation. Now it's time to change the position. Take it back. Now here you can see both clearly. Select the gear edge and shaft edge, and it comes here coincident relation. Okay. Now we can make here one more relation. This side also select big gear and small gear. Both face become coincident or parallel. Okay. Now it's time to give some relation. First adjust the gear position. Okay. Select mechanical mat, choose here gear. Select first small, then big. Ratio same 20 by 60 mm. Okay. Okay. Now let's try. Okay. Now you can observe here, this is our input shaft and this is output shaft. Now see the speed of shaft. This output we are rotating in slow motion, but the input is rotating very fast. So this is the main use and main function of a speed reducer. Now let's give the animation. Or keep perspective, no problem. Let's save the assembly. Solidworks assembly, save. Now I just adjust the size. Save. Now right click on the taskbar, choose here motion manager. Motion study, upward. Now here just drag the assembly up to 14 seconds. Now click here motor. Select this input shaft face and keep the speed 300 rpm. Here make sure rotary motor selected. Okay. Now select here calculate. See input shaft rotating very fast and output see very slow. So this is the main aim of this gear reducer. Now play. See the this side gear is rotating very fast and here are the very slow. You can see observe the shaft. This output shaft rotating very slow and input is very fast. So this is the main aim of gear reducer. Let's give some more relation, some exploded view. and take it out the gear shaft, up, again choose down, and here also take this shaft out, undo, better select first bearing out, just select undo and clear here. Now choose bearing, shaft, then select gear. Of course the gear will go up, again select the gear, okay, now take this shaft, undo, clear, undo. Let's see where this shaft will go. Okay, select the bearing, comes up, then come out, select this gear, this gear let's rotate, undo, select this shaft, now select this gear, now rotate this gear, again choose, undo, better clear, take bearing out, again choose, select this gear, select here blue line, undo, it's rotating in a wrong direction, clear those. This arrow also rotating, undo, or take it out this shaft, take this position. Okay, it is not perfect, but just right click here, collapse. Choose here animation wizard, exploded view, next. Start second 14 and here select 12, finish. Again select animation wizard, collapse 14 and here select 14 plus 12, 14 plus 12, I think let's keep 27, finish, calculate. Now you can see it's a simple animation. So I hope you like it. Please subscribe our channel for more video and more projects in SolidWorks. Don't forget to share and like our video. Thanks for watching.